Hey everyone, I just open sourced the framework to fine-tune or continue pre-training an LLM from zero to ready to use model in just a few clicks. Normally, I had to write 300 lines of code for each different task. I had to perform data sanitization to guardrail the LLM, and for each dataset schema, I had to implement different dataset preparation logic. For quick experimentation and jumping between hyperparameters, I found it very monotonous and time-consuming. So let me show you how I eliminated those redundant steps. Not just for me, you can use it as well. After finishing setup and running this script, we are an Upasak application powered by Streamlit. First, select a model from the available ones. More will be added soon. Then paste your Hugging Face access token. If you want to push your model to Hugging Face Hub, then paste your write access token. Otherwise, read access token is just fine. Then select a dataset to train your large language model on. Either you can select a dataset from the dropdown or you can choose to select your own dataset. Once the dataset is uploaded, you can either choose to enable PII sanitization to enable privacy aware training. You can go ahead with rule-based detection or you can check the AI-based detection for a hybrid approach which uses named entity recognition model. You can also manually verify the uncertain detection and choose to keep or discard them. So if you enabled human review or human verification table consisting of the uncertain detections will appear. I will discard all of them since I don't think any one of them is personal identifiable information or sensitive information. Once you have verified it, click on the verified button and this dataset will get sanitized. So here is the output sample of our sanitized data. As you can see, some of the personal identifiable information or sensitive information detected by our module has been replaced with the keyword redacted. After completion of data sanitization, you come here to the hyperparameter section, adjust your learning rate, patch size, epochs, logging steps, maximum sequence length for each sample, select your learning rate scheduler, and then you can also choose to adjust your advanced hyperparameters. Here I will change the checkpoint save strategy to epoch. I want checkpoints for my training every 5 steps. Then if you want to evaluate your model during training, you can choose the evaluation strategy. You can choose evaluation steps, and if you can select a ratio to split your data set into training and validation set. You can also select model tracking platform. You can select from weights and biases and Comet ML, and then you paste your model tracker API key here. Once this is done, you can start your training after entering your output directory path where your checkpoints and final model will be saved. But if you are looking for a parameter efficient fine tuning, you can enable LoRa, configure its hyperparameters, select its target modules. And if you want, you can also check the merge adapters box. So this will merge the adapters with the base model weights. So then let's start training. So as you can see, the data set is being tokenized right now, and soon the training will start. You can track the training directly here itself. For more detailed monitoring, you can choose to select Comet ML or weights and biases. As you can see, our training is completed since I just gave the very small data set. So as I mentioned, you can also track your training in Comet ML and weights and biases also. So let's look at that. So as you can see, you can directly come to Comet ML with your credentials and you can track very detailed logs and graphs. Once the training is finished, you can go to the directory whose path you have entered. As here you can see, checkpoints, final model, and merged adapters are saved. Along with that, ready to use inference script is also prepared. So you can directly check your fine-tuned model. In final model, you can find LoRa weights. In the merged adapters directory, you can find the combined weights of base model and LoRa adapter. After the training is completed and the model weights are saved, if you want to push your model to Hugging Face Hub, you just have to come here, enter your Hugging Face username, enter the name of your repository. Even if it is not created, it will be created. Just click on push to hub. Pushing your model and tokenizer to Hugging Face Hub might take few minutes. So let's wait. Once the uploading is finished, you can click this URL to access the uploaded model on Hugging Face Hub. So as you can see here, we have uploaded files, uploaded model weights and tokenizer as well. So this Upasak package provides a no-code or low-code framework for you to fine-tune your LLM or continue pre-training your LLM within just a few clicks. Upasak is 100% open source and no sign-up required. You can find installation and setup steps in the GitHub repo, link given below. Try it out and let me know what features can be added or if anything can be fixed. Do start the GitHub repo if you think it is helpful or if it saves your time. And this is the official GitHub repo of the Upasak package. You can find more details about the project in this GitHub repo. And as I mentioned earlier, you can find installation and setup steps for this project or package in this GitHub repo only. There are components and functions of this package which can be directly reused in your custom training pipeline. Upasak is also available as a Python package, so you will be able to directly install using PIP.